Hey everyone, it's Miss Lopez. This is the Chapter 2, Chemistry of Life, Part 1 notes on the properties of water. In this video, you're going to be able to explain how the properties of water that result from its polarity and hydrogen bonding affect its biological function. Now for this unit, we are going to cover parts of Chapter 2 and parts of Chapter 3. But for these notes specifically, we are going to focus on a little bit of review on atomic structure, and we're going to be looking at polarity and the properties of water of life. Starting with a little chemistry review, remember that atoms make up everything, including living and non-living matter. Now, when you look at the structure of an atom, there are several parts we're going to talk about. So number one is this center part, which is called the nucleus. In the nucleus, there are positively charged and neutrally charged particles. Positively ones are called protons, the neutral ones are called neutrons, but most of the time we focus on the electrons, which can be found orbiting around the nucleus. Now, the reason we focus on the electrons is because this is what's going to determine how atoms behave. And it's important to keep in mind that like charges will repel each other and different charges are going to attract. So, for example, you may have played around with magnets where you have two positive ends and you try to bring them together, and then you feel the push where they're pushing away from each other, whereas a positive and a negative end are attracted to each other. Most atoms are neutral because of the number of electrons equals the number of protons. If the numbers are not equal, there is a net charge. So we're going to do some practicing with the overall charges. Remember that your protons are positive and your electrons are negative. Neutrons are not factored in because they have no charge. So when you want to find out the overall charge of an atom, you would count up the number of protons, in this case 8, and you would add to it the number of electrons. Now electrons are negatively charged, so positive 8 plus negative 8 means your total charge is 0, or what we say neutral. Next, if we take positive 7 and add to it negative 6, remember that everything in this column is going to be essentially negative because these are negatively charged. So positive 7 plus negative 6 is going to equal a total charge of positive 1. Try to do the next few on your own. Pause the video now. And I just realized there was a typo on my notes. This value here should have been 1 like it is in your notebook. So then these are your two final answers. You have a charge of positive 2, and then since there are more negative than there is positives here, your overall charge is minus 1. Atoms with unfilled outer shells tend to undergo chemical reactions to fill their atom shells. So they can attain stability by sharing electrons with other atoms or by gaining or losing electrons. So molecules interact with each other by sharing or gaining those electrons. The atoms are then bonded together to form molecules. Chemical bond is an attractive force that links atoms together to form molecules. There are several kinds of chemical bonds. Carbon atoms have 4 electrons in the outer shell. They can form covalent bonds with 4 other atoms. Some notes regarding strength and stability. Covalent bonds are very strong. It takes a lot of energy to break them. And the interesting thing about carbon is that they can share more than 1 pair of electrons. So if it is a single bond between, let's say, 2 carbon atoms, then they're going to share 1 pair of electrons. And we typically draw it like this. So here is 1 carbon atom. Here's another carbon atom. And this line right here represents 1 pair of shared electrons holding these 2 carbons together. Carbon atoms can also form double bonds when they share 2 pairs of electrons, and it would look like this. Carbon atoms can also form triple bonds where they share 3 pairs of electrons, and that is what that would look like. the degree of sharing electrons is not always equal. There is a concept of electronegativity, which is the attractive force that an atomic nucleus exerts on the electrons. It depends on the number of protons and the distance between the nucleus and the electrons. When you have an uneven sharing of electrons, it results in what is known as polarity. So, how can you tell if something is polar? Well, remember that atoms are going to be neutral if the protons, or positively charged molecules, are equal to the electrons, which are negatively charged. So if one of those is out of balance, then you're going to end up with a net charge. If two atoms have similar electronegativities, they share electrons equally in what is called a nonpolar covalent bond. If atoms have different electronegativities, electrons tend to be near the most attractive atom in what is called a polar covalent bond. So here you have two models of water, which is the molecules we're going to be studying in this notes. And you can see how water, which is H2O, is made up of oxygen and two hydrogens. Now, these blue dots that are in between represent the electrons. And so what we're looking at are the outer electrons that are shared by the oxygen and the hydrogen. Now, oxygen is more electronegative than the hydrogen. In other words, oxygen is going to steal the electrons a little bit more away from the hydrogen. Because of this, oxygen ends up with a slightly negative charge, and the hydrogen ends up with a slightly positive charge. So the bonding for the water molecule is what is known as a polar covalent bond. It is a covalent bond, but it is considered polar because there ends up a net slight charge on the molecules. Hydrogen bonds will form as a result of those polar covalent bonds. Hydrogen bonds are attractions between the slightly negative end of one molecule and the slightly positive hydrogen end of another molecule. They form between the water molecules themselves, so two different water molecules. These hydrogen bonds are also important in the structure of DNA and proteins. So it's the hydrogen bonds that make water a very unique molecule. And this uniqueness is what we call properties of water. And there are several properties of water that are important to life. The first is the versatile solvent. Next are the properties of cohesion and adhesion. Next is the high heat capacity. Next is the high heat of vaporization. And last is the density differences between the solid water and liquid water. We're going to talk about a few of these in a little bit more detail. First is the versatile solvent. Any polar molecule can interact with any other polar molecule because of those hydrogen bonds. Hydrophilic, or what we call water-loving, in aqueous solutions, polar molecules become separated and surrounded by water molecules. We call this the sphere of hydration. Nonpolar molecules are called hydrophobic or water-hating. The interactions between them are hydrophobic interactions. You may remember some of these terms when talking about the plasma membrane. So in this diagram, they're showing you how water molecules are going to interact with hydrophilic substances. So you have a slightly negative charge here, and a slightly positive charge, and a slightly negative charge. This slightly negative charge is attracted to the charge on the hydrogen of this water molecule. Now remember that the hydrogen part of this water molecule is slightly positive. The oxygen, because it is more electronegative and takes the electrons away, is slightly negative. And so it's going to interact with the positive charge of this hydrophilic molecule. Hydrophobic molecules are not going to interact with water because they do not have charges. Their electrons are not being shared unevenly, and so neither the positive nor the negative end of the water molecules is attracted to any part of the hydrophobic molecule. Hydrogen bonds also give water cohesive strength or cohesion. Water molecules resist coming apart when placed under tension. This permits narrow columns of water to move from roots to the leaves of plants. So the property of cohesion and adhesion you can think of as a property where water is sticky or will interact with other molecules. The difference between cohesion and adhesion is what it is sticking to. So cohesion is water sticking to other water molecules. And again, that is hydrogen bonds that are forming between the molecules. Adhesion is when water sticks to something else that's polar. It could either be another polar substance, or it can even be a polar surface, such as the inside of the plants. Either way, the stickiness is due to the hydrogen bonding between the water, which is polar, and something else that is polar as well. Water molecules form multiple hydrogen bonds with each other, and this contributes to what is known as the high heat capacity. A lot of heat is required to raise the temperature of water. That is because the heat energy that is being input is being used to break the hydrogen bonds between the molecules. In organisms, the presence of water helps shields them from fluctuations in temperature, environmental temperatures. So in other words, as energy is being brought into this liquid water, instead of raising the temperature by making the molecules move faster, instead what's happening is that energy is being used to break down hydrogen bonds that are forming between the water molecules. This means that water does not fluctuate in temperature very quickly. It takes a lot of energy to raise the temperature of water by 1 degree, which is what the specific heat capacity is referring to. Now, students will get this often confused with the high heat of vaporization. The high heat of vaporization is a phase change. In other words, from liquid to solid or liquid to gas. The high heat capacity is referring to a temperature change, whereas the high heat of vaporization is referring to a phase change. In other words, solid, liquid, or gas. Water has a high heat of vaporization. A lot of heat is required to change water from the liquid to a gaseous state. Thus, evaporation has a cooling effect on the environment. And sweating cools the body. As sweat evaporates from the skin, it transforms some of the adjacent body heat. In other words, it's using the body heat to break those hydrogen bonds and change phases. And all that heat energy that is being absorbed is lost from your body, and that's why you cool down. Let's look at a practice MCQ on the properties of water. Figure 1 is a diagram of water molecules at the air-water interface at the surface of a pond. So they give you that this is the surface of the water. They have here the positive charge, the partial positive charge, and the partial negative charge. And let's look at the question. Based on figure 1, which of the following best describes how the properties of water at an air-water interface enable an insect to walk on the water surface? Go ahead and pause the video now, and I will reveal the answer. The correct answer choice is D. Remember that between individual water molecules, in other words, this part right here, it is hydrogen bonds that are going to form between the slight positive and the slight negative charge of the next molecule. So that right there is a hydrogen bond. So we can do process of elimination simply based on that one statement. Let's take a look at some of the other answer choices. For letter A, it starts off with covalent bonds between the water molecules, and I'm going to stop reading there. It is not covalent bonds between the water molecules. I don't even need to read the rest of the statement because that first 3 words, so those first 5 words, are enough to tell me that that's not going to be a correct answer. For the next one, Ionic bonds between the molecules at the surface of the water provide an electrical charge, which attract the feet of the insect, keeping it on the surface. Now, in chemistry, you learned that ionic bonds are going to form between metals and nonmetals, so that is also not a valid choice. For letter C, it says polar covalent bonds between molecules at the surface. And right there, I can stop reading because, again, it is not polar covalent bonds between the molecules. The polar covalent bonds are found within one water molecule. In other words, between H and the two H's and the O, not between entire molecules. So if we were looking at figure 1, the polar covalent bonds would be here, not in this part right here. These are hydrogen bonds. So I don't even need to finish reading the rest of that statement. This is already false within the first 5 words. So that's how not only do I know that D is the correct answer, but I've gone through and proven that the rest of them are incorrect. Thanks so much for watching this video. I hope it was helpful, and I'll see y'all next time.